Today our objective is to be able to multiply and divide integers by using patterns to develop rules for multiplication and division. Alright, so we're going to start with some multiplication values that we should already be familiar with. Alright, and we're going to take a look at the patterns of the products and use the patterns of the products to develop rules. So we're going to start with the multiplication sentence that says that 5 times 5 is equal to 25, right? All of us know that if we have 5 of something and we repeat that 5 times, we'll have a total of 25. We also know that 5 times 4 is going to be equal to 20. We know that 5 times 3 is equal to 15. We know that 5 times 2 is equal to 10. And we know that 5 times 1 is equal to 5. And we also know that 5 times 0 is equal to 0. And I'd like for us to look now at the pattern in our products. Right? We have products of 25, 20, 15, 10, 5, and 0. And if you look at the pattern in our products, we see that our products are decreasing by 5 each time. So if I continue that pattern in our products, we can predict what the next product is going to be. Well, let's take a look at our factors. Notice that the first factor has not changed in any number sentence, but the second factor has changed in each number sentence. Well, what's the pattern of the second factors in each number sentence? Well, the pattern is that second factor is decreasing by 1 each time. So if we look at the next number sentence in the pattern should be 5 times -1 is equal to what? Well, we see that the pattern is decreasing by 5 each time, and if I decrease 0 by 5, we wind up with -5 for that product of 5 times -1. And if I continue that pattern, right, I decrease the product by another 5. If I decrease -5 by another 5, that product's going to be -10. If I decrease that pattern, right, continue that pattern, right, I'd get -15. And I see then that the next 3 number sentences, show us a rule for multiplying a positive integer by a negative integer. Positive 5 times -1 gives us a product that's negative. 5 times -2 gives us a product that's negative. 5 times -3 gives us a product that's negative. Notice that 5 times 1 is equal to 5, and 5 times 2 is 10, and 5 times 3 is 15, right? So the multiplication part doesn't change. The only part that changes is the sign of the product, right? And if I wanted to write another number sentence, right, using that same pattern, right, it would be 5 times -4, right? And that's going to be -20, all right? So I'm going to use that pattern, right, to predict our second rule, right? So if I were to write a rule for this pattern, right, it would be that when we have a positive integer times a negative integer, the product is going to be negative. All right? So let's look at another number pattern. All right, so we just said that 5 times -4 is equal to -20. And we're going to use that as our starting point to develop our next rule. All right? So notice that my second factor now is going to stay the same. The first factor is going to decrease by 1 each time. And let's see how that's going to impact our products. Well, 4 times -4, we learned from the previous rule that that's going to be -16 because we have a positive 4 times a -4. 4 times 4 is 16, but a positive times a negative is going to be negative. 3 times -4 is going to be -12. 2 times -4 is going to be -8. 1 times -4 is going to be -4. And 0 times anything is 0. And let's look at the pattern in our products. We see that our products are decreasing by 4 each time. Right? That second factor stays the same, and that first factor is decreasing by 1. So if you were to write the next number sentence using that pattern, what would it be? Well, if I decrease 0 by 1, right, the next factor is going to be -1. We see that second factor stays the same, so that's going to be -4. But let's look at our pattern in our products. Right? Our products are actually increasing. Right? We're increasing by 4 each time. So we're actually moving right on the number line. Right? So what would the next product be? Well, if I increase 4 from 0, the next product would be positive 4. And if I continue that pattern, right, negative 2 would be my next factor, times negative 4. And if I continue my pattern in my products, that's going to be positive 8. Right? My next equation would be negative 3, right, times negative 4, and that's going to be equal to, right, positive 12. Well, let's look at our equations to develop a rule, right? And the rule would be when we have a negative factor times another negative factor, our product is in fact positive. A negative times a negative equals a positive. A negative times a negative equals a positive. All right? So to kind of sum it up, all right, let's sum it up. Here we have our rules. Well, the product or quotient of two integers with the same sign is positive, right? And notice we say or quotient, right? So let's see what happens with division. Long ago, you guys learned, I'm sure, that division is the inverse of multiplication. So we can create a division number sentence from our multiplication number sentences. So if we just learned that a positive times a positive is equal to a positive, right? 8 times 6 is 48. I can reverse that multiplication number sentence to show or create a division number sentence. 48 divided by 6 is equal to 8, and that's what I've written here. 48 divided by 6 is equal to 8. If I take my second multiplication number sentence, where we have a negative times a positive equals negative, negative 8 times 6 equals negative 48. If I want to reverse that to create a division number sentence, it would be negative 48 divided by 6 is equal to negative 8. And that's what we have here. Let's look at my next multiplication number sentence. Positive 8 times negative 6, we know, is equal to negative 48. Well, let's reverse that and see the division number sentence that that's going to create. Negative 48 divided by negative 6 equals positive 8. And that's what we see here. What this shows, though, is that the rules for division are the same as the rules for multiplication, right? A positive, right, or essentially, when the signs are the same, the quotient is positive. When the signs are the same, right, the product is positive. When the signs are the same, right, here I have two negatives, right, but they're still the same signs. So when the signs are the same, product is positive. Here I see my signs are the same, negative 48 divided by negative 6. The quotient's positive, all right? When the signs are opposite, right, here's multiplication sentence. When the signs are opposite, product is negative. When the signs are opposite, quotient's negative. So it comes down to these two rules, right? And the rules are very simple. It says that the product or quotient of two integers with the same sign is positive. The product or quotient of two integers with different signs or opposite signs is going to be negative, right? To sum it up, positive times positive is positive. Negative times negative is also going to be positive, right? Positive times negative is equal to negative. Negative times positive is equal to negative. All right, so let's do some examples here, okay? Oh, a couple more rules down here. I almost forgot. An odd number of negative factors gives you a negative product. An even number of negative factors gives you a positive product. And those two rules are going to be very helpful as well. So we also want to remember those two rules when we multiply. So if we're looking at these examples, right, very quickly, I look at 5 times 5. They're both positive, so I know that the product, right, that's going to be equal to 25, right? Product is going to be positive. Here I have two negative integers, right? But once again, they're the same sign, right? Same sign, product's going to be positive, positive 9. Here's an example of opposite sign, so I know the product's going to be negative, and 12 times 2 is 24. Here we have the zero property, 0 times anything, right? That's going to be equal to 0. All right? Here we have two positive integers. The product's going to be positive. 4 times 11 is 44. Here I have two negative integers, but once again the sign is the same. So the product's going to be positive, and 7 times 8 is 56. Here I have opposite signs, so I know the product's going to be negative, and 6 times 4 is 24. And this last example, I have an odd number of negative factors, so I know my product's negative, right? 5 times 4 is 20, and 20 times 7, 2 times 7 is 14, so that's going to be negative 140. Right there, I just used my my commutative property, where I changed the order of my multiplication. Okay, right, we have some division down here, but the rules are the same. If the signs are the same, the product or quotient is positive. If the signs are opposite, product or quotient is negative. All right, so 14 divided by 2, right, we know that that's going to be equal to 7, and it's going to be positive because the signs are the same. Negative 32 divided by negative 4, quotient's going to be positive, right? Because once again, I see that I have both of my integers are the same sign. So 32 divided by 4 is going to be 8, right? Negative 40 divided by negative 8, that's going to be positive 5, right? Signs are the same. Product or quotient is going to be positive. 0 divided by anything is going to be 0. Negative divided by positive, right? That's going to be negative. And 49 divided by 7, that's going to be 7. All right, and this last one, positive divided by negative, that's going to be negative, and 21 divided by 3 is going to be 7. All right, so it's just a matter of looking at our rules and using those rules over and over again. Right? Well, what happens if we want to evaluate some expressions? All right, so let's evaluate some expressions here. Right, if I want to evaluate the expressions, simply want to substitute. Right, so I'm going to substitute 8 where I see an x, and I'm going to substitute negative 4 where I see a y here. So this is going to be 10 minus, right, that's going to be 8 squared divided by y, we're going to replace with negative 4. Now, according to the order of operations, we have to do the exponent first. So that's going to be 10 minus 8 squared is going to be 64 divided by negative 4. Next, with our order of operations, we have to divide 64 and negative 4, right? And 64 divided by negative 4 is going to be what? That's 1, and that's 16. So that's going to be 10 minus 16, right? And 10 minus 16, we know that that's going to be negative 6. All right? If I try some of these examples down here, a divided by b, all right, I'm going to replace a with negative 18, all right, because we're told to up here. I'm going to replace b with negative 6. So this becomes a negative divided by a negative, which is positive, and 18 divided by 6, that's going to be 3. Next example, a number a plus 6 divided by 3, and a is negative 18. So that's negative 18. It's going to be plus 6 divided by 3. I take care of the numerator first. Negative 18 plus 6, negative 18 plus 6, that's going to be what? That's going to be negative 12 over 3, and negative 12 over 3, that's going to be negative 4. All right, and this last one here, replacing b with negative 6, but that's negative 6, got to be squared. That's going to be divided by a, which is negative 18, and then we're going to add 4. Well, negative 6 squared is going to be negative 6 times negative 6. It's going to be 36. So we have 36 over, let's give ourselves some more space, negative 18, and then we're going to add 4. Order of operations say we have to do the division next. So 36 divided by negative 18, positive divided by negative is going to be negative. All right, so that's going to be negative 2 plus 4, and negative 2 plus 4, that's going to be positive 2. All right, let's play around with some examples here. I always like to do this with my students using that bottom rule that we had on that other page. If we have an even number of negative factors, the product or quotient is positive. If we have an odd number of negative factors, the product or quotient is going to be negative. So this first example here, I have an even number of negative factors, so my product's going to be positive. Example 2, I have an odd number of negative factors, so my product's going to be negative. Example 3, we have an even number of negative factors. Product's going to be positive. Example 4, I have an even number of negative factors. Product's again going to be positive. Example 5, I have 1, 2, 3, 4, an odd number of negative factors. Product's going to be negative. All right, this next example 6, we have that multiplication property of 0. Right, so that's going to be neither, right? That's going to be 0, right? Which would be neither positive, right, or negative, right? And this last one, this one's a little tricky, right? Inside the bracket, we're going to have a negative value, but I want the opposite of the negative, right? So that's going to be positive. Or you could say, yeah, 1, 2, 3, 4 negative factors, an even number of negative factors. So your product is going to be positive. All right, let's look and see, get a little practice, right, with some exponents here, right? And these can be a little tricky, so we want to take our time with each one of these examples and understand the differences here. This first example says that -2 is our base, and we're going to use that -2 as a factor 2 times. So that's going to look like this: -2 times -2. Our base is -2. It's being used as a factor 2 times. Well, because I have an even number of negative factors, that product's going to be positive, and 2 times 2 is 4. Now, the second example is different than this first example, right? What do you see different, right? Yes, no parentheses. So because there's no parentheses here, -5 is not the base. The base is actually 5. Right, so that base of 5 is going to be used as a factor 2 times, but I want the opposite. I want the opposite of that product. So 5 times 5 is 25. I want the opposite of 25, which is going to be -25. That's always a place where students are going to make mistakes, but we have to really pay attention to what the base is in each one of these powers. Because the parentheses are around the entire -2, means that -2 is going to be the base, and that -2 is going to be used as a factor the exponent number of times, which is 2. In this next example, because there are no parentheses, the base is going to be the 5. The 5 is going to be squared or used as a factor 2 times, and we want the opposite of that. All right? And then this next example helps to kind of illustrate that a bit. What's the base number? Well, the base is -4. How many times is that base going to be used as a factor? Well, that base is going to be used as a factor 3 times, right? The exponent number of times. 4 times 4 is 16 times 4, which is 64. And because we have an odd number of negative factors, right, that product is going to be -64. All right? Let's take a look at these other examples here. In example 9, our base is going to be -3. And that -3 is going to be used as a factor 2 times, right? So that's going to be -3 times -3, and that's going to be +9 because I have an even number of negative factors. If I look at example 10, the base is -2. It's going to be used as a factor 3 times. So that's going to look like the following, right? -2 times -2 times -2. 2 times 2 is 4, times 2 is 8, but because I have an odd number of negative factors, right, my product's going to be negative. Right, here's the example that will sometimes, be confusing to students. This is the opposite of 7 squared. That's the way we want to read that. The opposite of 7 to the second power, which means that 7 is your base. Right, so that 7 is going to be used as a factor 2 times, but I want the opposite of that 7 squared. Right, so the opposite of 7 squared, 7 times 7 is 49. I want the opposite of that. It's going to be -49. All right, and then this last one, I want the opposite of 6 to the third power, which means 6 is the base, right? And that base is going to be used as a factor 3 times, but I want the opposite of that. 6 times 6 is 36 times 6 is 216, but I want the opposite of that. So -216 would be our answer there. All right, let's try a couple more where we want to now evaluate some expressions. We want to replace the variables with numbers. All right, and let's see. Oh, we did that. All right, so let's try these examples here. I'm going to replace y with, let's let's see, negative 5. So this is going to be 15 divided by negative 5. 15 divided by negative 5. That's going to be negative 3. Right? A positive divided by a negative is going to be a negative. Here I have x times y, so that's going to be 8 times negative 5, but then we have to divide that by negative 10. According to our order of operations, we do addition or multiplication and division from left to right. So I have to do the 8 times negative 5 first, and that's going to be negative 40, but then we have to divide that by negative 10. Negative divided by negative is positive. 40 divided by 10 is 4. So that's going to be positive 4. And this last example here, we have x plus y, so that's going to be 8 plus negative 5, all right? But that's in parentheses, okay? And then we have to divide that by negative 3, all right? So if I want to divide that by negative 3, all right, I have to first do what's in the parentheses, 8 plus negative 5, positive 8, and negative 5, that's going to be 3. But then I'm dividing that by negative 3, right? Positive divided by negative is going to be negative. 3 divided by 3 is 1. So we get negative 1, right, for our answer there. All right? And I think that's going to be it as far as our lesson goes, right? I've done all the problems that we wanted to do, so we're going to stop the video there, and I hope that that was helpful.